Oh, hey, how's it going? Back here with another video. Today I'm going to be talking about TimescaleDB, which is a time series database that's built on top of Postgres, which is an open source relational database, very popular, one of my favorite databases. You may be familiar with it already. I'm basically starting a new series. It's probably going to be like 7 or 8 videos. I'm going to first discuss what TimescaleDB is, how it might be useful to you, and I'm going to go into a few practical applications where I attempt to use it for some financial data applications and stock trading apps. You know what we do on this channel. Like and subscribe if you like what I'm doing, and buy me a drink if you want to contribute something to the channel. I'll leave a link below. So let's go ahead and get started with talking about TimescaleDB. This first video is going to be more about what is time series data, what is TimescaleDB, why do I care, that sort of thing. So I've written a few slides here, and I've went through the TimescaleDB documentation to attempt to understand it a bit better. So it's very new to me. So this is the perspective of someone that's just trying this out for the first time. But I think I'll cover some useful things to you. And in our past videos, we've used a SQLite, for instance, as a data store. And I think using TimescaleDB will offer some unique features that will be useful to you. All right. So first of all, I've made a few slides here with some bullet points so I remember what I'm going to cover. So this is an outline of where we're going in this particular series. So the first slide I have here is what is time series data, like what's unique about it. Why do you care? Why do we have to name data? Isn't it just data with a timestamp? What's unique about time series data? So time series data is just data that changes over time, and it means that your records have some type of timestamp associated with them. A few examples of that are, for instance, COVID-19 data. You see a chart over time showing how the virus has spread over time, where it's plateaued, if there's a second wave, those sorts of things. Very useful to people to make decisions and to have seasonal forecasts, things like that. Other examples that are very popular are that I used to work on a server monitoring software as a service application in the past, and we measured a lot of things like CPU and memory usage over time, and so we tracked that data minute by minute, and you could derive some interesting insights out of that data. So you could show a dashboard to the server administrator showing how CPU has changed over time with and monitor like thousands of machines, right? And if CPU spiked during a certain minute, and that corresponded to some other characteristics of memory, maybe the disk I/O or the memory usage, then you might be able to use it to detect anomalies or figure out something's wrong with a particular machine, or maybe in the future you might be able to determine that, in an hour from now, this server, we might need to look at that, right? So tracking this data over time is very useful. Other useful applications are Internet of Things devices, sensor data, tracking like wind and temperature over time, things like that. And so on this channel, as you know what we do, we like to use financial data. And so we're often tracking stock prices or crypto prices over time, whether that's, minute by minute, day by day, hour by hour, even second by second, and streaming in real-time data. Something like a specially customized extension for dealing with time series databases could be very useful to us, right? Because this provides a lot of aggregation functions. It speeds up our ingestion speed, so we can insert data really quickly. We can select data really quickly. We might have some useful analytics functions that we can use on time data so that we don't have to pull everything out, load it into a pandas data frame, write all these functions ourselves. There's a lot of cool stuff that's built in that's provided as an extension to PostgreSQL, and we can use also the Postgres functions to work with data as well. So the data can be captured at this time series data. We can either capture it at regular intervals, which is the case of historical candlestick data that we often load in. It's just data that's collected every 5 minutes or 15 minutes or whatever interval we decide. But there's also irregular intervals like events that we can track. And so that could be just like streaming in real-time bid and ask data for crypto. That's happening all the time, right? But it's not really a regular interval. It's just as they come in, we insert data. Another example of a case where data is enriched by timestamps. So the example I believe that Timescale uses is logins, right? So I don't necessarily, if I'm building a web application, I don't necessarily have to record a timestamp when someone logs in, right? Or I could just record a single like timestamp for the last time the user logged in, right? And that's useful, right? We know when they last logged in, but they give the example of what if we have a record for every single time a user has logged in history and record observations about that particular login, right? Then it becomes more and more useful to us. That data gets a lot of extra value because we can see if we record the IP address where the user logged in each time, we can see where this user moves around. If a user logs in 100 times a day, or every 5 minutes, then we know they're a very active user of our system. If a customer has not logged in a month, we might want to check on that person because they might cancel the service, right? And we can send them an email and say, hey, miss you lately, where you been, right? And that can help, maybe bring that customer back or help you find customers in advance that might cancel your software as a service application or whatever you're building. And so time series data is very important to understand, and using time series data very well can actually make your business more profitable. And it's also useful for us, obviously, since we're working with a lot of financial data and charts and technical analysis and things like that, right? Another unique characteristic of time series data is its immutability. And so most of the time you're just inserting data. So there's a lot of types of applications where you're going back and updating and making a lot of edits. But if we're just downloading a bunch of historical data, what happened in history is already recorded, right? And we can just archive that. We don't need to go back and update what the Dow Jones Industrial Average was in 1991. That data is always the same, right? And so with TimescaleDB, they can make certain optimizations for insertion speed, right? They don't have to worry so much about going back and updating certain types of data, right? And so you can just optimize for insert speed and also fast select. So I'm sure they've probably focused on those areas and also made some interesting features for data retention and like purging old data that we may no longer need, compressing that data, things like that if it's not accessed frequently. Okay. And so some practical uses for our case for time series data is pattern recognition, for instance. So a lot of times we're looking for particular chart patterns. A lot of people trade and say, oh, I want to find this triangle pattern or this 3-bar breakout, that sort of thing, right? And so that'll be one example video that I do. I'll probably do just a simple 3-bar breakout, and we can just find that using regular SQL and Postgres lead and lag functions, right? We don't have to pull all that data out, like tons of data, and then filter that down in a pandas data frame and do all that work. We can write one SQL query to find that and just pull out just the data we need. It's also useful for forecasting. So there's Python tools such as Facebook Profit that allows us to detect seasonality trends and do time series forecasting. We might be able to do some anomaly detection and detect unusual activity in options or something like that, or in unusual spikes in prices, maybe a GameStop short squeeze or something like that. Maybe GameStop is normally not very active, but we saw how crazy it was in the past week or so. And there's tons of other uses, and so I'm going to talk about those a little more in a moment. So why specifically TimescaleDB? So we've recognized the value of working with time series databases and needing some special tools to work with time series data. And so why specifically choose a TimescaleDB? And I have to talk about this because every time I've talked about a relational database on this channel, there's always a few people are like, why not use NoSQL? Isn't it faster? Isn't it better? And I think that is not necessarily the case. First of all, you probably won't even run into any of these problems that you're talking about. I've personally worked on multiple startups that have done very well and grown to become huge businesses, larger than anything you probably ever deal with, and certainly as just a project on this channel, right? And Postgres was the central database for the whole system, and even the application that I talked about that monitored tons of different desktops, hundreds of thousands of devices, it might be millions of devices at this point. Postgres was the central database that we used for everything. We had some Redis caching and things like that, but Postgres was at the central data store, and also I worked on a file syncing application where we recorded lots of data in Postgres as well. And so the claim that you can't use an SQL or relational database to work with time series database, I feel like, isn't true just from practical experience. But if that isn't enough, right, the Timescale folks have done a great job. You really need to read their blog because they have compared it. They've taken the time to compare TimescaleDB against other types of databases, specifically MongoDB, which is brought up a lot, and also InfluxDB, which is another time series database. And I have the links right here. And just to pull them up, they've measured and determined 260% higher insert performance, 54 times faster queries, simpler implementation. And so these blog posts are very detailed. These aren't just, isn't it faster? Like, they actually measured this and provided all the benchmarks they used, the type of data they used, right? And so this is an evaluation of insert performance, query performance, disk storage footprint, implementation costs. They go through multiple methods. They show the ingest rate right here. As you can see, at TimescaleDB, they benchmark it faster. Obviously, they're a little bit biased since this is written by TimescaleDB, but they do publish the actual setups they use. They showed disk usage, where lower is better, and so the compression must have been much better, so a 10 times smaller disk storage footprint. And you remember when we stored a lot of historical data for years and years for QQQ, for instance, we had a database that was like 3 gigabytes or so, and that wasn't even all the symbols. So you could imagine if we start pulling in like terabytes of price data, this footprint becomes very important because a lot of times we're just storing this on our desktop or on a virtual server, for instance. And also this discusses select performance. You see it's extremely fast there, and I'm not going to go through everything here, but just know, they specifically talk about MongoDB and the different recommended methods that the MongoDB folks say that you should use to store time series databases or time series data, and determine that a relational model here using TimescaleDB is much faster for both writes and reads. And this goes on, and it talks about the recommended setup from MongoDB as well, not just making it up as you go. They went through the best practices and everything, right? And then likewise, the same thing, InfluxDB is marketed as a great time series database as well. I've never personally tried it, but they do go through a detailed analysis on the data model, the query language, reliability, performance. So they talk about a number of reliability issues. And I personally worked in the gaming industry, and I do know folks that use MongoDB as their primary data store and did experience major problems in production at scale. And so I've heard this anecdotally as well. But one of the main focuses here is the data model and the language used. And what's cool about Timescale, if you're like me, is that it just used SQL. And I already know SQL. I've worked with SQL Server, MySQL, SQLite, Oracle, all these other databases, right? So I have this, years and years of knowledge of SQL, and I can use that immediately with TimescaleDB. I don't need to learn another language. And one issue with Influx is they've come out with like multiple versions of some query language. So there's this InfluxQL, and it's SQL-like, it's like SQL, but not quite. And so there's all these things you have to learn. And so, I don't want to read an entire manual necessarily to figure out how to implement all this stuff. And so you see, if I want to learn Influx, right, I have to go through all this and learn the stuff that's specific to just Influx, right? And just doing that takes so much time to get ramped up on. And really, is it any better? Right? And so by embracing SQL, you can use a lot of knowledge you already have, but also by embracing Postgres, right? We have this powerful database that's been around for decades. It's probably been around since the mid-90s, so over 20 years of experience built in, right? And all this tooling, so you have tools like SQL Alchemy and object relational mappers from Django, Flask, all these tools, right, that already work out of the box with Postgres, since the Python web application developers have basically embraced Postgres since the beginning. And so, why use this other database and learn this proprietary language that just works with one database? Use the knowledge that you already have. And so I like that. And then also, a lot of times people end up using another database like Influx just to store their time series data. And what's nice here, a lot of times I have a web application with users and other objects and documents and things like that, other relationships, tweets, whatever it is, and it's stored inside of a Postgres database, right? And just being able to use that same database for time series data is very nice. So just a high-level list of features that TimescaleDB provides us. The first is fast ingestion of time series data. So if we're retrieving historical data for like thousands of stocks, we should be able to just get minute bars with millions of minutes and just insert all of those into the database without it hanging up or locking up or any issues. And so it should be able to handle insertion of data as fast as we will need. It includes time-oriented analytics functions. So if you go through Timescale documentation, you see there's functions that are provided like histogram, right? So if you look at the SQL here, they have this histogram that they run on battery levels, so we can run that on our price data. They have interpolate, so you can interpolate from one data point to the next, so like draw a line, or in some cases we do this last observation carried forward. If you remember when there was gaps in our minute data, we just carried the last observation, the last price forward in time to fill those gaps. There's time bucketing functions and things like that. And I'm going to go into that in detail as soon as I get into the tutorial part. Continuous aggregates, so being able to roll up your minute data into 5-minute candlesticks or 15-minute candlesticks, or rolling up all your data into daily candlesticks. Data retention, so maybe you don't care about data that's older than 30 days and you just start dropping that data, right? You only need to care about the most recent data, so you can define policies for how to clean up this old data automatically so that you don't have to worry about that. Compression, so you can take up a smaller disk footprint as shown in the documentation, and you have the full availability of PostgreSQL tools and ecosystems. So, and one other thing I'll mention as far as just general credibility, like you see a new database system and you're like, should I trust this thing, right? But if you look on their page, like the folks behind this are very successful, very knowledgeable people. So if you read the blog and you look at the background of all these folks, these are like professors at Princeton that they know their database stuff, right? So they've dealt with lots of data at scale. It's not just marketing, right? They've benchmarked all this stuff. They provide plenty of examples and technical insight and talk about running this across multiple machines with thousands of devices and recording data really quickly at scale. And so I was very, very impressed by reading through their documentation. Okay. And then why Postgres, right? I don't feel like I need to say too much about it, but it's battle tested, right? It's scalable, fast. You can store whatever. You have the ability to join data. There's useful aggregate functions. It works well with your existing business data. So there's so much data that's in a relational database already. You can use triggers, stored procedures. You have relationships. And you can preserve referential integrity, all the benefits you get of a relational database, plus you get all the tooling that comes with Python web application frameworks like SQL Alchemy, the Django object relational mapper, right? You get PostgreSQL extensions. The most popular one that we hear about is PostGIS, which is very useful. I've worked on geographic applications before, so there's useful extensions for working with latitude and longitude and geometric shapes and all kinds of interesting things that you can store and write functions for. And if you care about storing JSON objects, which is a reason a lot of people use MongoDB, it can store JSON documents as well, and there's very useful functions for querying JSON data. So at a previous tool I built, just took blobs of JSON data and stored it. And that's one of the benefits of MongoDB, is that you don't have to maintain the schema. But if you just want a key and to store some JSON data, Postgres has been able to do that since Postgres 9, and they have this JSON-B format where you can do that, and they have these operators where you can like query for values of particular attributes in a JSON document, and it works really fast. It's really cool. And then, yeah, it's fully open source, so it's not owned by a publicly traded company. So, as you know, Oracle has acquired, Oracle is a multi-hundred-billion-dollar corporation that's publicly traded. They bought MySQL. People were concerned about that at the time. And Oracle, and Microsoft owns SQL Server, right? And so it's nice to have this database that's still, open source. And it's also used by many of the most successful companies, and that's why you trust Postgres, right? Who started off with this? I believe Instagram used this for many years as the sole data store, and then every company has this in some form. Reddit, Robinhood, basically all these companies. And so if it's good enough for these people, probably good enough for what you're doing with it, and will get you where you need to go. And so what are we going to do, right? That's a great overview. You can read the documentation for that. What happens on this channel is we're going to talk about some practical applications, and I'm going to show you how to build them from scratch. And here are the things I have planned to show you how to do. The first, we need to get TimescaleDB up and running, and so we're going to use Docker for that. And so I'm going to show you how to just install Docker and run TimescaleDB. And also, you may remember that recently in last month's video, I made something called TradeKit, which is a Docker container with a bunch of financial libraries built into it, and web frameworks, and also TimescaleDB. And so I want to show you how to get it set up out of that box and develop using that. That way we can just work on a common Docker image that has all of these dependencies already installed. I'm going to show you how to populate the database, right? So once we get up and running, we need to get some data to work with to even demonstrate anything. So we'll do the usual thing where we just retrieve a bunch of historical price data on stocks. And I was thinking, since the ARK funds and Cathie Wood are like super popular and hot right now, that we would just focus on like getting the CSVs from the ARK site. So the ARK Invest, right? They provide CSVs of all of their funds, like ARC-F and ARC-G and those types of things. And then they provide these daily CSV files. And what I figure is that we'll just download those CSVs and retrieve historical price data for all of the different stocks. So we can make like a little ETF database, store historical data, and maybe we want to track how the ARC funds change over time, because I know I feel weird about this, but like people are all like, whatever ARK fund bought that particular day, a lot of people are jumping on it. So we can kind of look at how their portfolio changes over time, new stocks they're investing in, and so forth. Not that I recommend you just blindly follow what Cathie Wood or Chamath or any of these popular folks now are doing, but it's something to look at. So ARK funds for the source of our historical data, and we'll probably use Alpaca or Interactive Brokers to retrieve the actual prices on these stocks. We're going to demonstrate some analytical functions. So there's a lot of functions built in, as I mentioned, like first, last, histogram, time buckets, time bucketing, last observation carried forward, interpolate, different functions that are provided. We'll use those functions on this data. We'll also use the features of continuous aggregates and retention policies and build a simple API on top of this. So I've been using Fast API on top of it, and so I thought I would spin up the old TradeKit and show you how to develop a web application and pretend you're selling, or as a subscription, an API service for some type of financial data, and you want to serve it up. I'm going to show you how to build an API and use TimescaleDB as the backend for that, and we'll just serve up the data in a variety of formats. We're going to use SQL to calculate some common indicators and also find some chart patterns in data. And so I've watched a few videos that other people have done, detected things manually previously. And so I want to show you how to automate some of that. So finding certain patterns in our data just using regular old SQL. And we'll probably use PostgreSQL, some other functions like stored procedures, or create a user-defined function that maybe can do some automation for us. So perhaps when a certain pattern is detected in the data, maybe we can automatically execute a trade or log a record to another table, that sort of thing. And then in a follow-up series, I want to focus on Plotly Dash. I've shown just regular Jinja templates and React a little bit in my mobile front end, but I have also been meaning to create a user interface using Plotly Dash for folks that just want to use pure Python, because I do a lot of JavaScript as well, but not everyone wants to mess with that. So another goal I have in the channel is to do a video on Plotly Dash. And also, I think it'd be good to do a crypto version of all of this. I've noticed, actually, one of my crypto videos is the most popular one now, even though I mainly meant to talk about stocks. And so I also like that crypto data is running nonstop. So when I'm working on this on the weekend, I can stream some data in and show some examples that way. So I'll probably do a crypto version of this as well. So yeah, that's an overview of where this is going, what TimescaleDB is, why you'd want to use it, why you care, and these are the things I'm going to do with it. So stay tuned for the next several videos as we explore TimescaleDB. Thanks a lot for watching. See you in the next video.